Hello, everybody. So we are starting our next section on hyperbolas. This will be the last section for this chapter. So hyperbolas can be defined by distance, like parabolas and ellipses and circles, and this is how we define it. Well, first of all, they look like this. They kind of look like two parabolas facing in opposite directions. But a hyperbola is the set of all points whose distances from these two foci, each focus point, is the same difference. So, for example, this ordered pair right here, which is on the hyperbola, if you were to measure the distance from to this focus and the distance to this focus, and then subtract those two differences, you would have some real number, and then take any other point, measure this distance to that focus and this distance to the other focus, subtract those two distances, you would have the same number. So the distances to the two foci have the same difference. And that can be kind of seen algebraically with these symbols. These are two hyperbolas in standard form, and they look a lot like the ellipse formula. They both have fractions, they both have squares everywhere, they both equal 1, but with the ellipse formula, it's an addition. With a hyperbola, it is subtraction. And again, with the ellipse, remember A was the major, that would tell you the major axis. So 2A would be the length of the major axis, and that would let you know if the ellipse was orientated horizontally or vertically. Well, here, the A is not necessarily the bigger one. Here, order matters because subtraction is not commutative. So the order matters. Whatever comes first, that is the A value. And since this A value is underneath the X, this hyperbola opens up left and right, like these two pictures. And here, if the A value is with the Y value, then this hyperbola opens up and down. Now, every hyperbola has a center, of course, which is HK, and it'll have two vertices. So each vertex will be A away from the center, and every hyperbola has two focus points or two foci, and they are C away from the center. There's more to it than just that. It has something called a transverse axis and a conjugate axis. So a chord or a line segment through the center of the hyperbola to each vertex, that is called the transverse axis. So this one's facing left and right. The transverse axis will also be facing left and right. This one's facing up and down, so the transverse axis would be vertical here. So the transverse axis goes through the midpoint, and its endpoints are the vertices. So remember that each vertex is A away from the center. So the transverse axis from the center is A away in both directions. So therefore, it's 2A long. The conjugate axis is perpendicular to the transverse axis. So in this case, the transverse axis would go left and right because it's connecting the two vertices. The conjugate axis would go up and down. But how far up and down? A B value up and a B value down. So the length of the conjugate axis is twice B. So here, the red is the transverse axis because it is touching both vertices in either case, and the blue is the conjugate axis. And of course, they're definitely perpendicular to each other. These help us in two things. They will help us graph our hyperbolas, and it will also help us identify the asymptotes. So let's get into it. We're going to graph hyperbolas. So it's a three-step process. We're going to, first of all, find the center, but then draw a box around the center. And that's going to help us. We're going to use the transverse and the conjugate axes to draw that box. And then once we have the box, we're just going to draw a diagonal line through the corners of the box, and those will act as our asymptotes. And then we sketch our hyperbola. So we're going to do two, one that's facing left and right, and one that's facing up and down. So starting off simple here, this is centered at the origin, and A always comes first. It doesn't matter who's bigger. A always comes first with hyperbolas because subtraction matters. So whatever comes first matters. And since the A is underneath the X value, that tells me my hyperbola is facing left and right. Well, in this case, A squared is 9, which means A is 3, which means the transverse axis is 6 long. Remember, it's always twice A. And B squared is 25, which means B is 5, which means the conjugate axis is 10 long. So let's graph these. So I will graph the transverse axis, and I'm going left and right because my A value is underneath the X. So I need to go to the left from the origin, from the center, to the left 3 and to the right 3. I'll make that thicker. And then the conjugate axis is 10 long, but it's 5 up and 5 down. Again, it's connected to the Y, so that should remind you that you're going up and down. So this should help you see that there's a box here. And I would just try to sketch the box. So these are all, like in architecture, these are all ghost lines. So you would just use these to guide you. You want to draw these faint when you're doing this in class. So I can kind of make them faint here, but I don't want to spend time doing that. So then once you have your box, that was step 1. Step 2 is to draw your asymptotes. So that's simply drawing a line through the diagonal of this rectangle. So I get my ID out, and we'll just keep it black, and from one corner to the other. And then I'm going to extend these. So these are the asymptotes. And part of your homework and part of your test will be to find the equations of these two lines. So these, I am going to spend some time making these lighter. And we'll dash because their hyperbolas or asymptotes are usually dashed. So this is the structure. So you're going to draw your hyperbola on top of all these ghost lines. And keeping in mind that this faces left and right. And as soon as you drew your transverse axis, you identified your vertices. So you've got a vertex right here, and you've got a vertex right here. And you're going to use the box and the asymptotes to guide you. So you freehand, you kind of curve up along. That's not great. And then up and down, kind of using the box and the asymptotes to guide you. And then over here, start with this vertex, curve up, don't cross the asymptote like I did, and then curve down. So this is terrible because drawing with my mouse is difficult. But freehanding it with a pencil and paper should be much better. So you start with your vertex, and you just sketch both sides of your hyperbola, letting the asymptotes guide you. So let's try again. This one is facing up and down. And the only reason I know that is because Y is mentioned first. You're subtracting, so order matters. Y is mentioned first, so that's going up and down. My A squared is 1, which means A is 1, so 2A is 2. My transversal axis will be 2 long, TWO. And then B squared is 16, which means B is 4, which means the conjugate axis will be 8 long. And I'm going to draw these. Let's try to do this one freehand. So transverse, the one I'm really concerned about, the one that touches the two vertices, it's going up and down because Y is mentioned first. So I go from the center, up 1 and down 1. It'd be something like that. And then my conjugate axis is underneath the second variable mentioned, X. So I'm going left and right. I'm going to the left 4 and to the right 4. So it's 8 long. And then I use that to draw this box here. So I start in one corner and I draw my box. Let me try and make this a little fainter. And then now I draw my vertices. Not my vertices, my what's it called? My asymptotes. So starting with one end of the one corner to the next. And then now, see if I've improved at all. Now I draw my hyperbola, finally. And the transverse axis ends at the vertices. So I've got a vertex here and a vertex here. And that should be enough to remind me that I'm going up and down. But looking at my equation, y is mentioned first, so I'm going up and down. And I'm going to try to draw this parabola-looking thing using the asymptotes to guide me. So I'm starting here, and I'm curving up and away, but in such a way that it's kind of hovering towards the asymptotes. So there's one half of my hyperbola, and then there's the other half. Don't cross that asymptote like I'm doing. I hope you get the idea. One more example. This one's more complicated only in that it's not centered at the origin anymore. Where is this one centered? It's the center is HK, and it's an ordered pair. Order matters. X comes first, then Y. So in this case, I hope you can see that the center is 10, -1. You can think of your transformations. This is to the right 10. This is down 1. So the center is 10, -1. The A is always mentioned first. So my A value is connected to the Y. So that tells me that my hyperbola is facing up and down. And this is A squared. So A is 4, which means 2A is 8. And the conjugate axis was the same length. So I'm going to draw a box here. First of all, let's open this up a bit. My center is 10, -1, so I just identify it with a little marker right there, and then try my best to draw first the transversal axis. So the transverse axis going up and down because Y is mentioned first. So from the origin up 4, and I'm sorry, I said the origin, from the center, and then from the center down 4. And then the conjugate axis, it's the second thing mentioned is X, so I'm moving left and right, left 4, and right 4. And then use that information to draw my box, which in this case happens to be a square. And once I have my box, I can draw my asymptotes. And once you have your asymptotes, you're almost done. You just fill in the rest with the actual hyperbola. So you still have to be careful here because a mistake can still happen. There are four corners here, and you realize, I hope, that Y was mentioned first, so you're facing up and down. Here is one vertex, here is the other. So from the vertex, you draw a smooth curve. It looks like a parabola, but it is not. Letting the box and the asymptotes guide you.